operating system allows the user to directly access such a system process and the system resource. It will be messed up. So somebody may abuse the privilege, then your system will be down, or you cannot guarantee the performance of your system. So current operating system split the user mode and the kernel mode. So if, for example, if you wanna write the data on the file system, the user program asks the kernel to write the data. Then the operating system mode is changed to the kernel mode. So this is kind of to protect the operation, to protect your operating system. At that time, the operating system has the mode bit. So mode bit is your entire system, kernel system. If mode bit set as 1, which means the user is using your operating system. However, if user asks to use the resource of your operating system, computer system, the mode bit is changed to this 0. Then the kernel, the system is in charge of the next operation. So the dual mode is actually the action to protect your system. So you don't want to, so for example, think about the room. Your room has very important stuff. So you don't want to let your friend, use your system. Instead, your friend may ask, I need the homework, I need the notebook. Then you can give tools or the handover the requested material to your friend, because you want to protect the area. So that is the similar situation to protect the system. That's the dual mode. So this is the slide to show how dual mode is working. So for example, if user process, the compiled program is running, then at that time, there are number of the library we will see later, such as system call, system library, or it's called the system API. So for example, when you read the data, user cannot read the data directly. Instead, you are going to use the library, system library, that is able to read the data. You are going to call that system library. Once you call that system library, then your kernel, your operating system mode is changed to the kernel mode. Then kernel is in charge of that. So that is this part. So this part, then you are able, your system is right now at this time, it's a kernel mode. Once the kernel read the data and return to the user, at that time your system mode is changed to the user, like this. I already explained the timer. Timer is kind of to pretend if there is something wrong in the system. So the computer system keep operating the action. So if to prevent such an unexpected infinite loop, for example, so there is a timer, tick tock, tick tock, tick tock. Then once it's 0, then interrupt signal. It's because the computer is basically sharing the resource, like the CPU, time sharing, so on. So we don't want to give all the resource to only one process or one user. Instead, we are going to share. Then at that time, the unexpected, the process use the entire resource. So there is a timer, like a 10, 9, 8, and so on. 1, 0. Then if 0 happen, so still the same user, same process is using the CPU resource. Then firstly, there is an interrupt signal. Then the operating system take time. This is called the timer. This is a part of your operating system. Then finally, we have the process management in operating system. We will discuss really a lot about the process management after the chapter 1 and chapter 2. maybe next next week we will start to discuss about the process management. So I'm going to skip this part. You will see the diagram a lot. So this one shows the very high level overview of the process data structure. So that's a good question. So Christopher asked, whenever we use the system resource, do I need to ask we need to change the kernel mode? You don't have to. The only way to change the user mode to the kernel mode to user mode is when you call system library. So automatically the operating system knows. So this system library should be operated under kernel mode. Then your operating system changes the mode bit to the 0, then your mode will be 0. Okay? Right, so we will see the system library. Okay. Let's continue. So this is a process, the data structure. So I strongly suggest to you the snapshot, the screenshot of this one. We will discuss a lot. So in other words, so you don't have to worry about right now this is basically the memory structure. So let me stop here. So this is the kind of the memory area. So as I introduced, what is the memory? Memory is array of address. So for example, 0000 to the FFFF. So it's a memory address. So when you double click, when you execute the command, so you have a.out, the executable program. From the GCC, you compile the a.c, then you have the a.out, the executable file. So basically this file, the executable file has a bunch of what? Sequence of instruction. So it has a number of instructions. So when you run the a.out or double click this one, this the sequence of instruction, bunch of instruction will be loaded into the memory. Like this.
Professor?
Yes.
Does it load the instructions themselves or they're stored somewhere else?
Copy, just copy. It's not just as it is copied. If you have the really big program, later during the memory management, so like it's a 1 GB size program, but my memory is 500 MB. There's no space. But do we really need the 1 GB of program at one time?
No.
We are going to chop. Then, as needed, we will load. So we will see that it's the paging approach in the memory management. So, but to simplify this process, let's say that this one will be loaded into the memory. But how? Somebody should arrange or organize, right? So, compiler. When compiler compile this a.c file to the a.out, compiler knows this data structure. Okay? So for example, there is a global variable area. Okay? And there is a heap. There is a stack. So there is the executable code. So for example, this executable code is a lower memory address always. Then the global variable. Do you remember in the object-oriented program or any programming class, your teacher, your instructor probably suggested do not use global variable a lot, right? Do you remember? If possible, use a local variable. Why? What is a global variable? Global variable, no matter where you are in your program, you are able to access this. How? So you can put the separate location of the global variable, like this, right next to the executable code. Okay? So it's a waste of space also. Local variable, if the block is out of block, local variable will be free. So it can be reused. However, this global variable will not be freed until entire program is ended. So this is a data structure for the process. So we will reserve the area of global variable. And also, because of the characteristic of global variable, this is open for public, like public means this part. Within the program, it's accessible. So you cannot guarantee. Sometimes it may be obvious, it may be you don't the error. So global variable, you should be careful. That is one reason. So, but it's much more complicated data structure. It's like the architecture design. Architect, when you build the house, you design this is a basement, this is a first floor, this is a layout, and this is a roof. And roof size is, the slope is 30 degrees. Very precisely designed this. Who is in charge of that? Compiler. Compiler know what? CPU, the processor. Processor eventually consumer of this data structure process. Right? Do you remember the last time from this CPU? The way CPU can access the data is from the memory. So memory is this one. So which means CPU should know details of the layout of this room. Then the CPU can find the data here and here and here. Then CPU actually let the compiler consider this layout when compiled. And when you compile the executable file, this executable file actually follow this design, the rule. Then when you start the program, then it will follow this architecture that CPU finally accesses. That's the reason. If your program is compiled for the Intel, the chip, you cannot run the executable file on AMD, right? Different processor. Why? Totally different. Not totally different, but anyway, different layout. So AMD used, for example, this much, the global variable, but this one may use this much. And sometimes the details of the location layout of your process may be different. That's the reason you cannot. However, what about the Java? You can compile once, run everywhere. Why?
Java uses the
virtual machine. So instead of directly layout this one, Java, Python is the same thing. Python uses a virtual machine. On the memory, reserve the Java virtual machine or JRE, Java Runtime Environment. Default is a 500 megabyte space on the memory. Then class will be loaded into the here. Inside the virtual machine, they have the same layout on top of memory. But this JRE depends on the CPU. But once you download and run the CPU, the JRE, Java virtual machine, it's exactly same layout. So Costco, do you like to go to Costco? The wholesale.
Yes.
If you go to Costco in US, so what about the Costco in Korea? They have exactly same layout. Once you enter, the right hand side there is a customer service and the pizza, and the first section is electronic device, and past the clothes, it's exactly the same thing. They have identical layout. The virtual machine is the same thing. So that's the difference. And however, this is a rough data structure. We will see more details of this one. Most of the operating system follow the very similar. The high-level architecture, like the text segment, is the programming code, compiled code instruction. And then the data segment is a global variable and the geofield variable as a default value. Then the heap and stack. What is the stack? First in, last out. Right? Do you remember that? Why? And that's the reason is here. The stack can be used for what? We can go into the loop or the block and the block and block inside the inner block. We cannot jump out at once. We can next block, next block, next block. First in, last out. So that is the stack. We use a lot of such a stack data structure in our computer program. So that will be used as stack, mostly temporary. Okay? Heap grows, like for example array. We use a lot of array data. So array has the pointer. So when you have the array size 1008, we do not keep the 1000 element over here. Instead, we have only the address of the A that point to somewhere available memory to save the storage of the process in the memory. Instead of using directly this one inside the process the data structure, we point. That's the reason we use a pointer or reference or address. All data management on the program language is the same thing. So array will be. So that is the location of the heap. Okay, that is the overview of the process management. We will see details of it in the chapter 3. Okay. So once you create the number of processes, so you may not see the memory address directly. Instead, you are able to monitor using command line, like the PS command. Will show the like this. So this is the command line command. The PS is the command to see the kind of the information about your memory, the structure. By showing the list of the processes. So we will see the more details of such a command during the exercise 1. The next part, definitely, where are they? The processes is in the memory. So memory management is the critical to get the better performance. So we will see the memory management after the process management. Then the file system. We discussed about the caching and so on. I'm going to quickly skip this part. Okay. Then computing architecture. I think I already introduced the computing architecture at the beginning part, so I'm not going to explain the details of this. But I strongly suggest you guys to read the textbook. It's almost 100 pages for chapter 1 and chapter 2, but it's worthwhile to remind and review your computing architecture knowledge and experience. Okay, so I'm going to pin out the important part of the computing architecture. Nowadays we are using not single processor, so multiple processes. So this is called SMP architecture, symmetric massive processor, which means, so what is the difference between the processor and CPU? I sometimes use the CPU and the processor interchangeably, right? So what is the difference? Is it really identical or any difference? It's almost the same. So almost the same. However, when we are saying the CPU is like this part. The CPU can process one thread of instruction. One thread of instruction. It has its own register. storage, temporary storage on the memory. And there is a this one is L1 cache, layer 1 cache, a very small size of cache. We talk about the cache. So one set of this one is called the CPU. If you have another CPU on the same board, like another CPU, okay? At that time, we call this one is core. One core, this is another core. So in this case, so if we have one core, it's called the dual core. So at the same time, it can process two thread of instruction. Parallel program will be possible. However, the limitation is it shares the cache. It shares the cache, which means it cannot really the different parallel processing. So it's hard for user to implement such a really the parallel processing in multi-core system. Then who is in charge of that? Mostly operating system, no. Then this the multi-core whatever is called the processor. Single core, dual core, multi-core. If that has one the board chip, this is called the processor. Sometimes you can have the multiple processor. So multiple processor. However, multiple processor, they do not share the cache, which means it will be hard. However, you can implement the parallel processing easily. Not that easy, but easier than the multi-core. Okay, so this is called the multiprocessor, the system. So this is called the dual core, the design, and eventually multi-core. So this one is called the NUMA architecture. NUMA is the most popular nowadays in the multiprocessor system. You can see the CPU, multiple CPU. Each CPU has their own memory, but they are connected. Through the memory channel, they are connected to each other. Because if we have the multiprocessor system, they do not share their cache information, right? Which means if something data is updated here, until this data is back to the memory, they are not able to access. They do not know whether you changed the data or not. So there is a memory channel to connect to each other. So this is called the non-uniform memory access system. It's called the NUMA architecture. So NUMA is nowadays it's developed by the IBM. So it's nowadays it's used for general purpose. Then eventually, if we have such a multiprocessor system, can be one computer. So one computer has the multiprocessor. So I have two the processor. So it's a multiprocessor. However, that is one computer system, one node. If you have such a node, multiple computer, that then connected mostly they are connected through the fiber channel or the network, which is called the cluster system. So cluster, they are not sharing even the memory. They are sharing what? Only the storage. In case if you have the storage area network like the SAN, then it can be the shared nothing is the cluster system. So like for example, if you know about the Hadoop cluster system, Hadoop is such a based on the cluster system. Each node, each computer, they do not know the memory data in other system. Instead, they are sharing only file system, the file storage. So this is, I think, the kind of common sense for the computer science student, our computing environment. So traditional computing environment, put everything in one. So I'm going to explain this computing environment in a couple of minutes. Very quickly to do that. Stop share. So a long time ago, we do not have internet, and we do not have much rich for the interface. Just one computer. Everything is in it. So it has a CPU, it has a memory, it has a storage, even interface, I/O, everything. So there's no internet connection, nothing. So instead, when you want to use this computing resource, you can connect using dummy terminal. And there is a dummy terminal with the keyboard and mouse, and this one you are able to use the computing resource. Sometimes this one has the printer, but printer is a very important output device, so you cannot access the printer. So you code the program and ask to the operator. Then operator actually print out and give it to you. When I joined the first job, I did this kind of thing. So I do the programming. So headquarters, the department asked me, so I need a list of customers, then I code and the program, then the submit job to the operator, then operator print out, then I pick up, then send back to the requester like that. So this is centralized. Traditional, the computing environment is centralized. Problem? Or even this one has the application, this one has the database, everything. Problem? Oh, the good news, the benefit or strength, really secure. No way to access this one without the dummy terminal and the permission. So it's secure, definitely. But the problem is it works well for a certain job. However, what if we have more and more customer database sizes grow and bigger? It's 100% capacity utilization. We need to upgrade. So upgrade, how can we upgrade? We need to entirely remove and migrate, make by the bigger one. But if this one is not enough, we need to do such a replacement. So it's a cost, really cost. For example, IBM computing, IBM uses such a centralized system from the 1970, 1980, even up to the 2000, they use such a centralized system. The G360, we sometimes call the mainframe. So mainframe, they use such a traditional approach. We'd like to address that issue because it's not scalable. How? 1980, 1990, if you remember at the time, I'm not sure whether you guys gone at the time, we have internet. And also PC, personal computing power, has been upgraded a lot. So why not? From the centralized system, we take out the job to the PC. So we share the job. You don't have to do everything in the centralized server. Instead, please bring some of the job to me because I'm able to do that. Then this one is connected to the network. So network. Even it doesn't have to be next to the computer system. Instead, at home through the internet, like the work at home nowadays. So this is called the downsizing. We downsize the server. Or this one is called the client. This one is client, is part, and this is a server. So CS architecture, client and server. So this is a client and server architecture. Okay. Then, why? Because we have a network, we have a PC power. Then, still it has a problem. So this is a downsizing. So when I joined the first job, so most of computing environment from the traditional to the client and server architecture. So I contribute a lot. So this server can be database server. This server can be web server. This server, so any server. Then the client. Problem. whenever you connect the network to the another computer, what happens? Process is created. So the only way to use the computing resource is the process, creating process. So there is a process, which means memory. So in this server, memory for this user, memory for this user, memory for this user, memory for this user, like that. For example, if you connect the network, if you connect the database connection to the database server, usually 10 to 15 megabyte memory is created, allocated. So what if I have 1 gigabyte? Then how many processes? You can create only 100 the client. But some part, half of part of memory can be used for the system and so on. Actually, it's a very few number of database connection are available. So it's a limitation. But do you think if we have 100 clients over here, how many of them are really active? How many of them are connected to the database server and retrieve the data? 100? No. Even though you connect to the UB server, so even though you connect the June for this class, you can drink, you can have the breakfast. Not all of them are actively working for that. It's true. Only 5 to 6 active connection, which means the other 95 are idle. They just a waste of memory. So we can address this problem by managing the transaction. Like this is the client, this is the server. But in between there is a middleware. It's called the transaction server or web application server in case of web application. So instead of directly connecting from client to the server, request. Then this transaction server has a dedicated connection to the server. Then if there is a request, allocate the available. That makes sense, right? So this is called 1, 2, 3, 3-tier architecture. The 3-tier architecture. So client and server is a 2-tier, then 3-tier architecture. So we still use a lot the 3-tier architecture, like the web application server or database application server. Something application server is in charge of such a middleware. This one has client and server. Server means serve by accepting the request and response to that request. This is a server. Client just a request and receive it. Why not? I can be server as well as a client. So this can be, I have a computer, this is a client and server. I have a computer, client and server. They can request each other. I have the computer, so client and server request each other. And request each other. We call this one as a peer, and peer. So peer to peer, the P2P. Computing architecture. If you want to download the movie illegally using torrent, anyone who uses torrent? I'm using. So when I download the movie or any contents using the P2P, which means I can be served. So somebody, this is my computer and download. While I'm downloading the file, this will be transferred to each other. I can be client, I request, I need this file, and download. While downloading, I can serve for other. So that is the P2P. There's no exactly who is server, who is a client. By the way, when you download such a movie, if you watch the movie for your personal entertainment, so which means not broadcasting, it's not illegal. Right?
Yeah, I think I heard that.
Okay, so that is the P2P. The next one is, nowadays, I have a computer then connected. So do I need to have the database? Do I need to have the Microsoft Excel, such a thing? Instead, we are going to use. There is a company provider like the Amazon or Google, Microsoft. They have computing resource like this. So instead of installing everything on the local computer or the local infrastructure using the network, internet, then I'm going to use the computing resource and the provider. This time I can set up my computing environment by myself, what I want, on demand. So this one is mine. But next day it can be changed like this. As long as I can use the requested resource, it's fine. From the provider point of view, if the computing resources are not being used, they can allocate to the other user. It's called the virtualization. Using the virtualization, we can serve for many requests. Then you don't have to pay entire system. Instead, you can pay only for what you use. So this is a cloud computing environment. So nowadays, quickly change cloud computing environment. IaaS, infrastructure as a service. What is it? A? Platform. This should be platform. Platform, AAS. Right? So like for example, web development platform, or some component-based platform, or the Django platform. So for development purpose. Infrastructure is I need the network, and I need a router, I need the server. So this is infrastructure as a service, but platform as a service. Then software as a service, like right now you are using a lot. The Google, the slide, Google Doc, so such a software as a service. Nowadays, X as a service, which means anything can be service. Even service as a service. For example, you don't have to spend a lot of time for the deep learning modeling. Instead, you can use the deep learning model as a service, then you can focus on one application, for example. So that is the service. So this is a computing environment, the quick history. This is very important for your future. Why? We don't know. Very close. But it is true. Nowadays, quickly move on to the cloud computing environment, which means 10 years ago, a lot of students would like to get the certificate from the network security, like the CCNP and so on. But nowadays, cloud, AWS, or the Google, GCP, the certificate for your job. Okay. Then move back to this one. So I already explained. Oh, that one more thing is mobile. Mobile doesn't change entire the computing environment. However, mobile change our personal platform. So even including me and most of people, they are holding. Each person is holding at least one computer. It's a mobile device. So we need to consider such a mobile computing environment also for developing purpose, like the programming. It's a change. And the service definitely change. So it's a mobile computing environment. So it looks like the operating system is important, but unfortunately nowadays not many students, even the CS major, they are not much interested in the operating system. Why? There's not many opportunity job posting that directly related to the operating system, because as I said, our computing environment move on the cloud computing, which means the cloud computing, the service provider, they are in charge of all the infrastructure and the network setting and operating system and so on. The first priority is the abstraction. They try to hide behind. What you want to know is interface only. That's a service. But that's good for non-computer science major. So they don't have to worry about the details, what is the interrupt, what is the synchronization, and so on. But your major is in computer science. So you are not going to be, some of you guys will be architect or the salesman in the AWS. At that time, you should know the name of service and so on. But many of you guys will work for the software development or the design and so on. At the time, what is the bottom line of your service? It's the computer. Computer related to the performance. In case the performance is down, why? You should know. You should be able to understand the situation. Without understanding such a computing architecture as well as operating system, it's very hard. Why my program is running slowly? For example, global variable is located in the lower part of memory. Why the operating system always reside on the lower part of memory? It's for performance. So because of that, even though you are not going to contribute on the Linux, the new kernel, or the open source, the project, but it's really important for the better performance of the computer system and the programming by understanding the operating system. Okay, and operating system require even the most important part, I believe, of the operating system is the memory. CPU, you cannot change the design or whatever, but memory is the most critical part to address the problem of the performance. Okay, how to use it. That's the reason a lot of the system architect or such a computer organization class offer the project like the memory management, like the MRO, using the MRO, whether you are able to assign the memory space, or whether you are able to read the data from memory or write the data memory, and so on. So that is the purpose of the study of the operating system. Also, if you are interested in the kernel rebuild or system programming, so there are a lot of opportunity to contribute on open source project. It doesn't have to be commercial, the operating system or kernel rebuild, but there are some opportunity, many, the research purpose or educational purpose, sometimes hobby. As a hobby, you can rebuild new operating system and so on. Okay, that's the end of chapter 1. Let me see a lot of questions. Java virtual machine and yeah. It's not when I say the legal and illegal. So if you download the word, it's like this, it's the same as your friend gave the movie file. Then you watch on your laptop. That's it. Then that's not the illegal. However, if you broadcast such a movie file which is not the project, then for the like I put the screen outside and people watch and or the party, that should be the problem. So for the individual entertainment, so it's okay. In my case, so I download I'm from Korea, so it's been almost 20 years after I left my home country, but I still watch the movie or the drama, which is not easy to access from here. They block based on the network location, so that's the reason I'm using a lot. Okay, Napster, you probably do not know Napster. Napster was the most popular P2P application before for the music, but Napster finally is bankrupt. I think the still name is there, but it's the content provider, they sue the Napster, then the Napster is gone. Okay. There is chapter 2 and the start. And I'm going to share. Okay, so chapter 2 is also still the introduction of the operating system, focusing on the overview of operating system. So it will not be very difficult to understand. It's just relax and sit back, then read the textbook after the class. Please read the textbook. That's very important to understand. I cannot explain each and every detail so of the the contents of the operating system. So if there is any missing part or the skip part, so you guys can get the bridge such that I missed. So this is of the operating system. First, so we have the user interface. I know you are familiar with the graphical user interface. For example, Microsoft has a desktop, and Mac OS has one. Anyone who uses the Mac OS? So it's called Aqua. So it was the 1995 when I saw the first Aqua, the Mac. The interface is a 1995. So when I had a chance to stay the dormitory in University of Hawaii, so my roommate used at the time the Apple, the old Mac. So he should, at the time I have used the Windows 3.1. I'm not sure whether you guys ever used the 3.1, the Windows operating system. It's the starting of the Windows. Actually, from the 3.0, Bill Gates started the concept of Windows. I think the 90% of success of Microsoft is such a rectangular shaped interface, which is called the Windows, right? So I was really shocked when I saw the first time 3.1, such a rectangular interface. But even when I saw the first Aqua, the 1995, it's really it's still the very similar the interface as the current Mac OS. They use the toolbar button and something it's pastel tone the color, so something like that. So that is a user interface. However, I'm going to point out the importance of the command line interface. So that's the reason I'm going to have a couple of times of exercise lab to learn about the command line. It is true. So when the operating system has been developed and implemented, enhanced, so they are based on the command line interface. Then, for example, using the shell and the shell script and the shell command, so the computer, actually the operating system create a new command based on the command line interface. Then later it can be transferred to the graphical user interface. So to understand the very basic, and not very basic, the fundamental of the computer architecture and operating system, the command line actually much easier and close to the operating system. And also, if we are able to use the command line interface, it looks like what? Professional. Instead of clicking, you can type. It's like the hacker from the movie, right? So, but it's still more efficient to do your job. So please get familiar with the command line interface, if you are not, especially the line editor. So the first struggle from the student who don't want to use command line is the line editor, like the VI, VIM, or the Nano, and so on. So please be familiar with it. It takes a couple of hours to learn. Then, so you are able to use. The next part is, as I mentioned many times, program execution. What happens when you plug in the power? Creating the first process, and child processes, and the child processes, and so on. So this is called the program execution. Then I/O operation and file system we will cover throughout the semester. There are more the operating system functionality. Definitely nowadays, because after the centralized system, we need to communicate each other network. So communication, but communication does not mean the inter-communication, so intra-communication between the node and computer, but also it include the inter-communication between the process in one server. So we have multiple processes. They are working together sometimes, so we need to communicate each other. So like when you stay at home, so sometimes you guys do not know what the other student next room are doing, but you better communicate each other. How? You can see the bulletin board at the entrance door. So using the bulletin board, you are able to communicate. Or you can connect directly using the iMessenger. So this is another way. Computer provides exactly same the algorithm to communicate among the processes. So we will see the how. This is called the inter-process communication, IPC. So IPC is also important part of the operating system. Then error detection, so on. Let me see any question. Then, for your reminder of the operating system, the definition, so what is the operating system? We learned three parts: resource allocation. So we are going to share the limited resource for many users, many processes, and coordinate, control, and allocation. So these are, then you should implement. That's the part of operating system functionality. So resource allocation and the control, coordinate. Also plus the logging, protection, and security. But in this semester, we are not going to cover protection and security part. We may not have enough time to discuss all of this. So basically, this is one slide that shows all the operating system functionality. So we are not going to cover hardware in this class. You probably learn from the computing architecture. On top of that, we are going to cover this operating system. To understand this the operating system, we will discuss the program execution, I/O operation, file system, and also inter-process communication, not intra. Intra you will learn from the network class. Okay, so network class you will cover the intra, the communication, but inter-communication we will discuss in this class. And the resource allocation, some part of resource allocation, but not the accounting and the protection and security. Error detection, part of it. So we will cover this part. Then the system library. So basically, it's time to little bit talk about the project. Maybe next time I will discuss more detail. What you're gonna do in your project one is you are going to implement this part, command line interface, using system library. So you will implement the interface program to use your operating system. So at that time, you are going to use the system library. This is the first priority. To do that, unfortunately, operating system does not provide all different program languages system library. Instead, they provide mostly C or C++ library. So best choice is C or C++, the program language. I know. So some of the students are not familiar with the C or the C++ or the such a thing. So you can use the Python, or Java is not recommended. Java you can do, you can pretend, but you may not, because Java is basically based on what? Virtual machine, as I said. So you may not create, you can pretend the creating process. But actually that's not process, that's a thread. We will discuss later. So Java is not recommended, but Python, other part, interpreter, program language, they support two execution, like the pretend. As long as your program has the library, programming library, or the program package that create process. So if you can find like the C++ or .NET also the Windows API provide such a creating process system library. So this is the main part of the first project. You are able to create a new child process. Then for that process you can assign the job, like the list. ls, you can actually put the programming code for the ls. You don't have to do that. ls is already there, so you can copy. So we will see more details. So this is the first project task. Okay, and the optional second project will be file system. So you will get used to the operating system through the project. We will discuss more, maybe next week. I will introduce more details about the project once we cover a little bit part of the process management. Okay. So command line interpreter. So by the way, what is the difference between the interpreter and the compiler? First, both of them are the same in terms of what? Program. Yeah, they are program. It's a translate.
Compiler converts the code into bytecode.
Interpreter.
Just
Same thing. Both of them is a translator from your program language, high-level language, like the C, C++, or the C core. So such a high level. When I'm saying the high-level language means what? It's close to human language or close to computer?
Close to
Human, definitely. So we cannot understand computer language, machine language, assembly language. Some of them, few of them, but most of us, we cannot understand that directly. It's very, very tough and hard. Instead, we are going to use our own language. When you see Java, when you see Python, when you see Perl, when you see any language, high-level language, very close to what? English. It's a human language. So we are able to use such the high-level language. Then this one should be translated into what? Machine language. Who is in charge of the both? Compiler and interpreter. Then what are the difference between them? Compiler is like for example, I'm going to translate the entire book. So I need to understand the feeling and the intention of the author and the meaning between the line and so on. Then finally I can translate and go back and fix that. That is kind of compiler. Compiler, to translate the entire code all together. Then create what? Object file. Then this object file will be combined with the shared library, then load into the memory, finally executable on the memory. So this is compiler. On the other hand, the interpreter is when you are using Google Translator. Some of you guys are very familiar with Google Translator. You are not going to translate entire text, right? Instead, word by word, line by line. So this is an interpreter. So interpreter is the line by line, command line compiler. Okay? Then it doesn't actually it cannot skip or move to the certain part. Instead, it's a sequence of line. So you don't know whether later part is the error or not until you reach that command. That is an interpreter. So, but I can call the Python. Python is the interpreter or compiler? interpreter. Python is an interpreter. Why? Even though you have the error at the line, the end of the line of a Python code, so sometimes it doesn't cause any error if that doesn't reach that part, right? So it actually doesn't compile your code. It's a line by line. So why the Python? Just like the C or the other Java, I code the Python. It's called the Python script. It will be divided by the line by line, then compile it. It's an interpreter. Then, when we are saying the command line use command line interpreter. It's a line by line, command by command, to run the program. That program is called the shell program. As I introduced, shell is shell, moves outside. So kernel is compute, the operating system is inside, but we are not able to directly access. There are several reasons, security reason, protection, and so on. Instead, we are going to use an interface program that is command line, as well as a GUI, especially if you are using the interpreter that is the command line interpreter. Then think about what is the difference between the command line and GUI. GUI is not interpreter. It's an interface. However, command line interface is actually interpreter. It understands your what? The code request that create the child process. Which one is close to the concept of operating system? Command line or GUI? Command line, operating system create the kernel process, next child process. The command line follow the exactly same architecture of the operating system. That's the reason the power user or the developer, they don't like the Windows, the operating system, because it's all GUI. So it doesn't follow when they are doing something, the computer performance related job. So that is the reason I emphasize on the using command line, at least in this class. Okay. So this is command line interface. If you are using Mac, you already have. What about the Windows? I have cmd.exe. CMD is interpreter or not? It's not interpreter. It's the same as a GUI, but it's a pretend. Once the Bill Gates gave up the Microsoft DOS, so throw away those, then they keep the Windows only from the Windows 98, after 95. Then they do not have command line interface, only click. That caused a huge problem, so complain a lot. Finally, recently, the Windows 2020 April, they accept the Linux, the system, as a part of Windows. So you are able to create the Windows, Linux kernel on the Windows. It's called the WSL, Windows, something Linux. So you are able to create this. So your Linux kernel is not pretending Linux. It's not virtual machine. Actually, they are using virtual machine VM technology behind, but you are going to create the Linux kernel on top of Windows system. It's different from what? The VMware. VMware is a software-based the virtual machine, but the WSL is based on their kernel is changing. So from now on, you are able to use command line or you can pretend the command line interface on the Windows using Cygwin. You can download the software Cygwin. Or you can download the bash git. Bash git provide the git as well as the bash the shell. This is an example of Bourne shell. Actually the G shell. So G shell and Bourne shell are the best. Bourne shell is the most popular one. There the child, the descendant is the bash shell, born again shell. So bash shell is most popular nowadays. Then G shell is the kind of twin. It's almost the same as a Bash, but Apple, they try to put different name there on. So basically exactly identical. So when you are using G shell, so you can say I'm using Bash. Or you can use the same command, you can use the same script. I'm not going to explain details about the GUI. Also, GUI is very interesting. So user interface is part of HCI. It's a human-computer interaction area in computer science. Nowadays, this interface is a huge problem. It's quickly changed to the touchless, and the motion-activated speech recognition. So I believe such a human-computer interaction will be hot, very important. For example, Microsoft invests a lot of money last 10 years for hologram. Hologram maybe. So when we are doing the online class, so you just watch the screen like that, but maybe 5 years later, so the hologram will be here. So you can watch the 3D shape at home. So that we can have an online lecture using hologram, and the student over here, like the Star Wars movie. So you can ask Yoda. So then there is a hologram. But Microsoft, technically they implement, but they need some business strategy and so on. It will be soon. If you click the link below, you can see the history of the graphical user interface. Okay, let me see. Like this one. I'm going to skip this part. We have only a couple of minutes. So this is a history of the graphical. This is early GUI from the Xerox. Believe it or not, Xerox is not only copy machine. They are the IT company before, but nowadays. But their interface, if you take a look at this, it's very similar as well. The current interface, like we have a screen. You can see the screen over here. You can have the keyboard, and there's a mouse. Believe it or not, there is a mouse point. You can see that this is a mouse point, like that. Okay. I have used a similar the interface before. It's the file management, the interface. So it's the source, place, and destination. Source, left-hand side is source, right-hand side is destination. And this is the desktop, the GUI. So you probably never used here. I have used the KD desktop, and then this is the my recent one, Windows 95 OS, and finally we have the Mac Aqua, and this is current, the OS, the GUI. And quickly move on to the mobile interface like the touch screen. Then this is a system interface between user and the kernel. As I said, we discussed about the dual mode at the beginning. Then, when we need the dual mode, system kernel mode, whenever you call the system library, call system library, it will be changed. What is the system call? So the end user want, or the program want to use the system resource. They cannot directly access the system resource. Instead, operating system provides the library, programming library, that is the system library. So if you are using this system library, which is called the system programming. Sometimes when you search a job, you can see the 5 years of the system programming. If you don't understand what is the system programming, you cannot apply. So if you are able to use the system library, so that is the system programming. Then there are different types of the API. So for example, the Windows has the Windows 32 API. So in your project, if you are able to use the Windows 32 API, fine. And the Unix and Linux and including Mac OS, okay, this is the most popular, and the Linux system. Java has the Java API, but this is based on the virtual machine. So once you create the virtual machine, the process on your memory, then the inside. So they will take care of the creating process as a thread like that. So there are three different major the system core system API, the Windows Win32 API, and the Linux system and Unix system POSIX API, and then Java API. So this is an example of using the system API, but I'm going to skip this part. And all the operating system provides such a reference, the guide. So for example, this is a Linux system, example of a Linux system, the system library. So you can see this one. If you want to check the file status, so F step is the file status. And if you want to create the file, you can use a fork and the exec. If you want to create open a file, you can use the open the API like this. So this is the system library. How many? System function, system library. How many? Usually 100 level, 1,000 level, or the 10,000 level. How many? Usually 200, sometimes less than 200. It's not really a lot. So think about from the low-level system, what you can do: read, write, modify, check. So actually there are not any system functions we need. Instead, the application program use this one and do a lot of things. Sometimes you may not use this. Why? You may not know. Your programming API already used. Okay? So for example, print in Python, print use system library behind. However, this print is the function provided by the method provided by the Python. So Python user, they do not know the behind, only use the print when you display the data. So that's the reason you may not realize the system library, but system library are used a lot behind the program. Okay, so I think let me stop here. Here. And stop sharing. First chapter. Checking. Okay. What about the yes? That is the interpreter also. Yeah, Windows subsystem for Linux, WSL. So I during the summer, during the pandemic, I tested Ubuntu and the CentOS and two Linux systems same time on my old Windows. It works well. Windows 10. If you have a Windows 10, please test it. Search the WSL, the Windows subsystem for Linux. Then you need to update. Windows update, and it's not very difficult to install. Then you are able to use the Linux system as well as the Windows. Regarding to the homework, the due date is this Friday. So it's just find the definition of some given keyword. So even though I do not cover everything, but you are able to do. So please write down the answer using the Word or the electronic, or I don't suggest you write on the handwritten, then take the photo and submit it. Instead, you can type. Okay, so then submit it. Usually, as you realize, the due date is Friday, but available until the end of the weekend. So, but please try to do your best to submit on time. There's no late penalty, even though you submit during the weekend, but after the Sunday, it will be late penalty. Okay, any other questions? Yes, I heard that the last time the textbook is in bookstore, so you guys can pick up, right?
Yeah, it's at the bookstore.
Yes, so you already paid, so please go to the bookstore. They are giving ebook. Did you get the ebook or the?
No, I got the hard copy.
Some of them already got the hard copy. I do not know how to get the ebook. Is there anyone who got the ebook here? Not here. Please share your experience. I do not receive any information. Please contact the bookstore, then ask the ebook code.